Welcome to tutorial 3.2 part 1 on predicting chemical reactions. So what we did in 3.1 is that we learned how to write reactions, how to write equations for reactions, and how to balance them. What we'd like to do now is at least make a prediction for the simplest type of reactions. Given some reactions, try to figure out what the products would be, and then write out the balanced equation for that. Alright, so let's just go through a series of examples. That's going to be the best way to proceed. So look at the format first of all. Here's an example. If you're given an element like a metal and a non-metal, you know how to find the formula for that ionic compound that results, in this case, magnesium oxide. After that, you have to remember how to put the phases in for the various elements and the compounds, and all these ionic compounds that we make will be solids at room temperature. The others, you have to keep track of the trends that we learned back in chapter 2. And then just balance the equation like we did before. So let's give it a shot. Let's see how it turns out for the first one. It says, write the balanced chemical equation for the making of barium nitride from its elements. So barium nitride starts with barium. That's a solid at room temperature. Plus, to make the nitride, I need some nitrogen. And I remember that that is a gas at room temperature, and it comes as a diatomic molecule. Now, what's barium nitride? So barium nitride is a substance which is made up of 3 bariums for every 2 nitrogens. How do I know that? Barium has a +2 charge, so it's going to lose 2 electrons apiece, and the nitrogen over here is going to gain 3 electrons apiece. So for the electron exchange to balance out, I need 3 bariums for every 2 nitrogens. Great, so we have the formulas. The phases, hopefully you kept track of that. All of these are solids. The gas over on the right hand side, these 4 here, bromine's a liquid and iodine is a solid. So now let's go ahead and balance it. In order for this to balance out, we need 3 bariums in the front. And it looks like everything else is balanced. The 2 nitrogens are on both sides, so we can check that. And what's nice is that it goes ahead and it rewrites it, formats it for you properly. So at least look at the equation when you're done. Say, oh yeah, that's how I'd format it if I could put in all the subscripts, etc., etc. Let's try the next one. Write the balanced chemical equation for the making of strontium selenide. So strontium is Sr. And selenide is Se, and those are both solids at room temperature. I need to put a plus sign, a space between them. And now what's the charges on these? Well, the strontium is +2 and selenium is -2, so they're all balanced out. And the whole equation is balanced out, so we can just check that one right away and say, yeah, that looks right. And then it reformats it for us and says it looks pretty good. Let's try at least one more. Write the balanced equation for barium selenide. So this time it's barium. And again, selenium, which we just had a second ago. Again, it's going to be pretty straightforward. It's a +2 with a -2 charge, so it's going to be just BASE. And we'll check that one and say that that looks pretty good. Oh, it says your equation is not correct. Oh, look what I did here. Look, I put an uppercase S. So that's the kind of stuff you got to be careful of. And try not to do that. Now we're all set. I think that's good enough. I think you get the idea. Yes, I'm happy to do 1 or 2 more. I'll look at 3 minutes. Let me do a few more. But you get the idea. You just use the skills that you've had before and just kind of put them together in one setting. So let's try this one last one. Potassium iodide from its elements. So potassium is K. That's a solid at room temperature. And iodine is also a solid at room temperature. It's diatomic. And the formula for potassium iodide is Ki, because K will lose 1 electron and I will gain 1. So now we have to do a little work to balance. I'm going to need 2 of these potassium iodides, and therefore I'll need 2 potassiums. And that looks pretty good. I think that's maybe good enough. So practice these on your own. And the thing is, a couple things to keep in mind here. Number one, we're not claiming that all of these compounds exist under some kind of odd specialized condition. Perhaps they do, but we're just trying to do an exercise here of trying to say if there's a metal and a non-metal given as elements, actually I can predict what the compound will be. That shouldn't give me too much trouble. All right, give these a shot, and if it's confusing, we'll talk about it in class. Great, thank you. Bye.